All right, 922. We'll go through this pretty quickly. To review from 921, we're just going to look at a couple more complicated multi-step inequalities just to kind of review our process of solving. I know sometimes we get a break from it, and sometimes we forget about some basic rules. So we have the first inequality, 3m plus 2 is less than or equal to 8m minus 8. First thing we want to do is get our variables on the same side. So we're going to draw a line. I'm going to subtract 3m, leaving me with 2. Keep my inequality, 5m minus 8. Add 8 on both sides. 10 less than or equal to 5m, and divide by 5. Because I'm dividing by a positive, no reason to switch my sign. So my answer is 2 less than or equal to m. And if I wanted to switch that around, I have to switch everything around. So m greater than or equal to 2. And that would be the solution set, or solution set for 3m plus 2 is less than or equal to 8m minus 8. Looking at B. B, there's a lot to get confused on or to lose. So what I'm going to do, I'm going to take this minus sign, and I'm going to change it to add the opposite. I'm going to do that with both of these. That way I avoid losing my negatives. Have to distribute. So 2 negative 3 times x is minus 3x. Negative 3 times negative 1 leaves me with a 3. Everything else stays the same. Combine, I get 5 minus 3x. Add 3x on both sides. 5 is greater than or equal to 4x minus 7. Add 7. 12 greater than or equal to 4x. And again, divide by 4 because I'm dividing by a positive. No need to switch my sign. And again, if I want to rewrite this, have to switch everything around. So either one of these would be okay. Oh, and you can't see that. I'm going to slide up. There you go. So 3 greater than or equal to x, or rewritten as x less than or equal to 3. Last one for review. C, 3y plus 1 less than 3y plus 1. Right off the bat, you might think, wait, how does that work? Everything on the left less than everything on the right, and they're the same. That's not possible. So let's prove that through our solving process. Take away 1. 3y is less than 3y. Probably still thinking that still doesn't make sense. Divide by 3. Y is less than y. Well, y can never be less than y. So this is going to be an inequality with no solution. No solution. All right, so now we're going to look at modeling. This is the last quick piece before we jump into some new information. We're going to look at 2 problems. We're going to look at 2 problems. So I'm going to take these right from our textbook, but I'm going to show them to you here. Ooh, a little glitchy there. The United Nations. So I'm going to read this problem for us. It says, at the end of this chapter, your team will have the exciting responsibility of representing a country at the special meeting of the United Nations. The UN needs your help preparing for future large-scale disasters. You will need to help find a solution that not only works best for the country you represent, but that also accommodates the needs of each of the other countries. To prepare you for this task, the next several lessons will present daily problems to familiarize with important issues and concerns of other countries. Start by writing and solving an equation or system of equations that represents the problem below. Now I want to key in to our word here. Here, they kind of switched it on us. An equation. They want us to write an equation here. So we're going to look at just familiarizing ourselves with writing equations and then translate into inequalities when they ask for inequality. And then the last part, define your variable. We did this with let statements. So we're going to continue with that idea. So here's the problem. Turkey has a population of 66 million people and is made up almost entirely of 2 ethnic groups, Turks and Kurds. There are 4 times more Turks than Kurds. write an equation and solve it to find out how many kurds live in Turkey. So I'm going to have you pause the video now and try to write this, and then unpause and we'll walk through it. All right, so first thing I'm going to do is I'm going to write my let statements. Let T equal number of Turks. Let K equal number of Kurds. All right, so it tells us that the population of Turkey altogether is 66 million people. So that tells us, our first equation, that the Turks plus the Kurds will equal 66 million total people. All right, so that's an equation about people. Now we're going to write a relationship between Turks and Kurds. I'm going to read that. There are 4 times more Turks than Kurds. All right, so my number of Turks is going to be equal to 4 times my number of Kurds. We're going to go ahead. It asks us to solve, so we're going to review that. This is a system. I have a variable defined, so I'm going to use substitution. So I'm going to take this 4K. I'm going to plug it in for T in my other equation, giving me, I'm going to do it over on this side here, 4K plus K equals 66 million. That means 5K equals 60, that's a weird 6, million. And I'm going to divide both sides by 5, giving me my number of Kurds, which is 13,200,000. Now to find my Turks, I'm going to take that Kurd number and I'm going to plug it in for K, giving me the number of Turks is 4 times 13,200,000. And my number of Turks is 52,800,000. So that's just a nice review of kind of representing us modeling a situation, as well as solving a system of equations. So this was equations, not inequalities. So let's go ahead and look at modeling with an inequality. In 1912, Japan gave the United States several thousand flowering cherry trees as a symbol of friendship. Similarly, the nation of Cameroon plans to give flowering sada trees, I think it's sada, we'll go with sada, to other countries this year. When asked how to decide which sada trees make good gifts, Cameroon's chief arborist explained, "We plant sada trees when they are 6 centimeters tall and they grow 9 centimeters every year. The trees only flower when they are taller than 150 centimeters." Okay. It is very important that the trees Cameroon gives flower this year. It would be considered an insult to receive a tree that does not bloom. Luckily, Cameroon has many groves of sada trees from which to select. How old must the sada trees be so that they will flower within the year? Okay. So if we go back to our problem, we plant right here, we plant sada trees when they're 6 centimeters tall and they grow 9 centimeters per year. All right, we have constant growth here. So we're dealing with a linear model, right? A linear model. Now, the last part says the trees only flower when they are taller. So we're comparing, taller than, I should say, 150. So now we know it's an inequality versus an equation. Okay, let me grab my sheet here. So we're looking at 958. Why don't you go ahead and pause the video actually here, and we can have you try it, and then we'll compare in a second. All right. We plant sada trees when they are 6 centimeters tall and they grow 9 centimeters per year. Sorry for the crinkling. Here it is. All right. The trees only flower when they are taller than 150 centimeters. Okay. So our growth, we're thinking linear, right? So y equals mx plus b. y equals mx plus b. We don't need this part, right? We're just kind of focused on the linear part, mx plus b. So we have 9 centimeters of growth. That's our slope per year. Now we really should have defined that. So let's say let x be number of years. And when they start with an initial height of 6. That is a 6. That's a B. Make sure they're different. The trees only flower when they are taller than 150. That means they have to be greater than 150. Can't be equal to, have to be greater. Perfect. All right, so now when we go ahead and solve, 9x greater than 144, divide by 9, and x is greater than 16. So what does that tell us? Well, it tells us that our trees, basically how old the trees have to be. Determine how old the trees have to be so that they will flower this year. The trees have to be greater than 16 years to flower. And that's a nice just review of kind of that modeling process, kind of helping us move forward in chapter 9.